Back to another mathematics session. O'Neill McLeod is the name. And for today's class, we'll be looking at how we calculate the means from a group frequency distribution table. At the last class, we looked at the measures of central tendencies as it relates to the ungroup distribution table. Today, we'll be looking at the group distribution table. Now, before we get into our calculations, there are some reminders, or there are some important things that we need to highlight. Why is it that we have to group the data in this sense? Now, in the case where there is a large number of values, a large number of measures dealing with, it is wise, it is best for us to place the data in groups. Now, in this case, you realize that we have a question on the board and it says the frequency table shows the heights of 25 students. The frequency table shows the heights of 25 students. Now, if you notice, we have 25 students dealing with. And for us to list all 25 students like that, it would be somewhat tedious. So because we have a large number of measures dealing with, then it's best for us to group our data. Now, there are some things that we need to understand as it relates to our table here. Now, the grouping of the data, we refer to that each group as a class or a class interval. So notice in our table here, the height in centimeter, it says 140 to 144. Now, that's one grouping. What we're saying is that all those students who would have measured 140 to 144 centimeters, just about those measurements, would fall inside of that group. Now, each group is referred to as a class. Each group is referred to as a class or class interval. So if I look there and I say to you, what would be our third class interval? Then our third class interval would have been 150 to 154. Now, with that said, we also need to take a minute and look at those two numbers, the n numbers in each class. Now, the n numbers in each class, we refer to those as our class limits. The n values in each class, we refer to them as our class limits. Now, what is it that I'm actually saying? Here, 140 to 144. So we are saying that we could have 140, 141, 142, 143, and 144. Now notice all those numbers, all those values would actually fall inside of that class. Now, the n values, we refer to them as our class limits. So we have two limits. The value to our left here is called our lower limit. So that's our lower limit. Good. While the value here is referred to as our upper limit. So we have two limits, our lower limit to our left and our upper limit to our right. So for each group has two limits. Good, our lower limit and our upper limit. Now, here, to do our calculation here, remember, we really don't know the numbers that fall inside of this particular group right now. We really don't know the numbers that fall inside that particular group. It could be any number out of this set. It could be any of those numbers that fall in that group. Now, unlike when we did our calculation as it relates to the mean from the ungroup table, where we know exactly what number was there, then we could have gone ahead and multiply the frequency times the scores, or the frequency times the measure that we have over there. Unlike that, this is somewhat different. Now, in this case, we need to use a number that we can actually use to represent each group. We need to use a number that we can actually use to represent each group. Now, what would be the best number? Now, the best number to use would have been our midpoint, Now, as you notice here, I would have constructed my table with the mid interval value, because we need those values in order to do our calculation when it comes on to the mean. Now, the mid interval value, how do we go about finding those values? Now, there are many ways that you can actually find the mid interval value. One, we could write them out like that. We could write out all the values like that. Then we go and we identify our middle value, or the median value right here. So that's one way that we could actually identify our mid-interval value here. But there's another way that we can also find that, all right? And to find our mid-interval value, we can also find the average of the limits. We can also find the average of our limit. Now, remember I said to you that there are two limits, the lower limit and our upper limit. If we take the average of our limits, it will give us our mid-interval value. So here we could say our mid-interval value is equal to our lower limit plus our upper limit divided by 2. So that's another way that we can actually find our mid-interval value. Now, what is our lower limit here? It would have been 140. So that would have been 140 plus 144. And that now we divide it by 2. Now, if you notice here that this would end up giving me 284 divided by 2. 284 divided by 2, and 284 divided by 2 would end up giving us 142. So there we have it. We can find our mid-interval value two ways. Now, this one is not recommended. This one, I would not recommend this one, because some of the time the class size could be 10, it could be 20. So we don't want to be sitting down writing out all of those values just to identify the one that falls in the middle. We can just easily go to this formula where we use the average of the limits to find our mid-interval value. Now, in this case, why it is important that we actually go ahead and find the mid-interval value? Now, what we're doing here is that we need a value to represent each class here. We need a value to represent each class. So let us say we're assuming that all the students in this class or this group, the height of those students would have been 142. So we are here making an assumption, right, that all the students in this particular group will have a height of 142 centimeters. That's what we're actually doing here. So we're making an assumption. All right. So we can go ahead and we can find all the midpoint values there. So let's just fill in that column quickly. All right. So for this one, it would have been, and you could just work with me. We could do the second one, which is 145 plus 149, and that divided by 2, and that should give us 147. All right, so this would have been 147. All right, now here I can tell you that the next one would have given you 152. The next one will give you 157. Now, how do I know that without doing my calculation? Now, here, when I work out my first mid-interval value here, I realize that it is 142. The second one would have been 147. You notice what happens here is that all I did was to add 5 to 142, which gives me 147. 5 to 147 would have given me 152. I add 5 more, that would be 157, and I could add 5 more, and I keep on going like that. So there's a trend, there's a pattern that we picked up early, and we can just easily go through with that pattern. All right. So if I add 5 here, it is going to give me 162. 5 more would give me 167. And then no, this would have been 172. All right, so those are now my midpoint values. Those are now my midpoint values. Now, having our midpoint values now, it makes life easier for us now to do our calculation as it relates to the mean. Remember, we're just assuming that all the students in the group of 140 to 144 would have a height of 142. We're assuming also that the students in the group 145 to 149 would have a height of 147. So we're actually making an assumption. Now, let me just hasten to say to you that as it relates to the group distribution table, when we do our calculation as it relates to the mean for this table, then it is safe to say it is an estimated mean. It is an estimated mean. But why? Because we don't know for sure the numbers that fall in each group. We are just making an assumption here by using the midpoint to represent the entire group. We're making an assumption by using the midpoint to represent the entire group. All right. So because we're actually assuming, we're estimating this thing here, then the final result will be an approximate. It's an estimated. All right. I can tell you, however, it will not be far off, because if you would have done approximation before, you know that approximation is like an intelligent guess. All right, something close to the exact amount, maybe a little bit above or a little bit below. All right, so we're actually doing an estimation here. Now, because we have the mid-interval values now representing each group, then we can go ahead now and do our calculation. All right. Now, in this case, we're saying that we have only one student with a height of 142. All right. We have 3 students with a height of 147. Remember when we look at the ungroup data, when it was like this that we have on the board, we went ahead and we wrote them out, wrote it on the board, where 142 would have been written one time. 147 would have written 3 times, and we keep doing it like that. All right. Then we went ahead and we add them all up. All right. We add them all up and get our fx, and then we did our division there. In this case, we're using the mid interval to multiply our frequency, or vice versa, our frequency to multiply our mid interval. So let's go and do our calculation here. Now, 1 times 142 will give me 142. Now, 3 times 147 will actually give me 441. Now, 11 times 152 will end up giving me 1672. 7 times 157 will end up giving me 10. Good. 2 times this will give me 324. 0 times this will give me 0. 1 times 172 will end up giving me 172. All right. So we have all our values there. I could just do a quick check to see if all is correct there. Okay. Yes. Good. Have it looking good there. Now at this stage, what we'll be doing here is to find the sum down here. But what is it that we're finding the sum of? Now notice here that good. So what I could actually do here is to have f x, and I am going to just put a little subscript m there. I'm going to have my little subscript m. All right. Now, what does that mean? All this is saying to you is that yes, the x subscript m is coming from our data values over here. It's coming from the height. Good. However, that little subscript m is just saying to you that it is the midpoint of the heights that we're dealing with, the midpoint of each group. All right. So when I put that little subscript m, you will not necessarily see it in the books and so forth, but I tend to just use things like that to help students to better understand what we're actually doing. So it is the frequency times the class midpoints. That's what is happening. So when we go ahead now and we sum our fxm, we should get an answer here, which is the sum of fxm, and this is now equal to 3,850. That's the sum of our fxm there. No? With that said, we can now go and we can actually calculate our mean from the frequency table, and it's a group frequency table. So in this case, to find our mean, from the group frequency table, we're going to be using the sum of fxm divided by the sum of f. So we're using the sum of fxm divided by the sum of f. Remember, we already had the sum of fxm right here, which is 3,850. All right. Now, the sum of f is right here, which is now 25. So we can just plug those into our formulas, and that should give us our answer, our estimated mean. So this would have been 3,850 divided by 25. Now, having done that, we can just now punch that into the calculator. So let me just check that. 3850 divided by 25, and that would now give me 154 centimeters. All right. So here, what we're actually doing is that we're estimating now that our mean height for those 25 students would have been 154 centimeters. Now, that's how we go about calculating the mean from our frequency distribution group table. All right, or frequency distribution group table. So there are a number of things that we can quickly recap as it relates to this lesson. One, the reason for our groups would be that if we have a large number of measures dealing with, then it is always best for us to have them placed in groups. All right, so that's one. Remember, it's 25 students. So because we have so many students dealing with now, we place them in groups. Now, each group is referred to as a class or a class interval. Good. Each group is referred to as a class or a class interval. Now, with each group, there are two limits. With each group, there are two limits. Each group, there are two limits. The upper limit and the lower limit. The lower limit to your left, the upper limit to your right. So for my first class here, my lower limit would have been 140, while my upper limit would have been 144. All right. Now, we went on to say that in order for us to be able to calculate our mean, then we need a number that we can actually use to represent each group. We need a number that we can use to represent each group. Now, the best number to use would have been the mid-interval value of the group. The mid-interval value of the group. In this case, the mid-interval value would have been 142. What is it that we're actually saying here? We're assuming, we're making an assumption that the students, all the students who actually falls in this group would have had a height of 142 centimeters. That's what we're doing there. All right. Now, how do we find the mid-interval value? The easiest way to do that is just to find the average of the limits. The average of the limits will actually give us our mid-interval values. Now, after completing that, then we're saying that one student, we assume that one student will have a height of 142, three students had a height of 147, and it goes on like that. Notice here, we're multiplying the frequency against the mid-interval values, which now we label as our FXM column. XM just tells you that it is the mid-interval value there. The M suggests that it's the midpoint that we're talking about here. All right. Now, having done that, we now find the sum of our FX. We find the sum of our FXM, which gives us 3,850. And that will be divided by the number of students in this particular survey. Now, having done that, then that's the formula. Here, our estimate height, mean height, would have been 154. Now, that's how we go about finding the mean from the group distribution table. Hope you'd have learned something today, and I look forward to seeing you another time. Have yourself a wonderful rest of the day.